Section 11.2, Combinations. A combination is a selection of a group of objects taken from a larger group for which the kinds of objects selected is important, but the order is not important. Okay, so order doesn't matter, signifies combinations. Okay, so how many ways could the combination of 3 digits be made from the digits 1, 2, 3, 4, and 5 without repetition? So, how many ways could we arrange these? The idea is 1, 2, 3 now is going to be the same as 3, 2, 1. It's still arranging. So imagine if I had a five-sided dice, it wouldn't matter if the first dice was a 3, the second one was a 2, and the third one was a 1. That would be the same as if it was 1, 2, 3. That would still be the same roll. Okay? So first of all, we have to look at how many ways can we arrange 3 items from 5 digits. Okay, so this is from before. That would be 5p3, okay, which is like 5 factorial over 5 minus 3 factorial. In other words, that's 5 times 4 times 3 times 2 times 1 over, this is simply going to be 2 factorial, 2 factorial. Okay, so we see the 2 and the 1 cancels out. We just get 5 times 4, which is 20, times 3 is 60. Okay, so there's 60 ways to arrange 3 items, but those 3 digits can be arranged in how many ways? So how many ways can we arrange 3 digits? Okay, we could do this, we could do that. I could go 2, 3, 1, 2, 1, 3. I'm going to guess 6. How many ways can we do 3 digits? So 3p3. Okay, so here I get 3 factorial over 0 factorial. We said that 0 factorial is just 1. So I have 3 times 2 times 1 over 1, and I get 6. Okay, so to make combinations of 3 objects from 5 objects is simply going to be 60 over 6 or 10 ways. Okay, so there's 10 different ways to have groupings of 3 of the numbers 1, 2, 3, 4, and 5. There's 10 of them. Okay. I don't know why that's there, because my mouse is there. Problem. There we go. Okay, so the notation you will see is NCR. So this is again on your calculator, a button on your calculator, or sometimes it's also written in a bracket and it's N over R like that. It represents the number of combinations of N items taken R at a time, where N is greater than or equal to R, and R is greater than or equal to 0. We saw that NCR is the same as NPR divided by R factorial. So just expanding this, I would get N factorial over N minus R factorial. That's what NPR is. And I am dividing this by R factorial. Okay. So when you divide by something, that's like saying it's timesing by its reciprocal. So if I had like 1/2 over 3, that's like 1/2 times 1/3, or 1/6. Okay, so similarly here we could have n factorial over r factorial, n minus r factorial. So this is the formula for NCR. And yes, you have a calculator button that looks like this, NCR. Sometimes using this will be advantageous though. Okay, so from the previous example, we have 5 objects. How many different ways can we combine? 3 of them. So using the formula, it would be 5 factorial over 3 factorial, 5 minus 3 factorial. This is simply 5 over 3, 2. Okay. Solving, we would get 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. That's 3 factorial. We're multiplying that by 2 factorial. So I have 3, 2, 1 cancel out. I have 20 over 2, which is simply 10. We got the same answer this way. Okay. Express in factorial notation and simplify. Okay, so there's sometimes where they'll just give us variables and we actually have to do algebra. We have to show our prowess. So here we have n minus 1 C3 and we're timesing that by 1 over n minus 2 C3. So let's look at what this is first of all. N minus 1 C3. Okay, and we're timesing by 1 over, that's the same as dividing by n minus 2 C3. So we can't use our calculator because we don't know what n is. Using the formula, this is going to be n minus 1 factorial over 3 factorial, n minus 1 minus 3 factorial. Okay, so I just simplified this. Now I'm going to simplify the bottom. This is n minus 2 factorial over 2 factorial, n minus 2 minus 2. 3. 3, sorry. This should have been a 3 here as well. That's where this number came in. Okay, and now we need to simplify. Okay, so that n minus 1 factorial is n minus 1 times n minus 2 times n minus 3 times n minus 4, n minus 5, and it's going to keep going till 1. That's divided by 3 factorial, so that's 3 times 2 times 1, times n minus 1 minus 3. Well, minus 1 minus 3 is n minus 4 factorial. So n minus 4 factorial starts looking like this. N minus 4 times n minus 5 and keeps going until 1. Okay. I'm dividing by a fraction. When you divide by a fraction, you kiss and flip. So I'm going to put n minus 2 factorial on the bottom. Well, that's n minus 2 times n minus 3 times n minus 4, and so on, all the way to 1. Okay. On the top, I have 3 factorial, so 3 times 2 times 1. And then I have n minus 5 factorial. So it's n minus 5, n minus 6, and so on until 1. Okay, we should see some things that are going to reduce here. I have everything from n minus 4 and less here. N minus 4 and less there. So all of this cancels out. Okay. Here, everything from n minus 5 onwards. So you can imagine that after n minus 4, we would get n minus 5. Everything there would cancel out. Even though we didn't write it, you can imagine it would go n minus 4, n minus 5, n minus 6. Keeps getting lower. Okay, so that all cancels. What I'm left with is n minus 1, n minus 2, n minus 3, and here I have 3 times 2 times 1, and on the bottom I have 3 times 2 times 1 times n minus 2, n minus 3, n minus 4. So I could have done this in the last step, but we can see there's even more that would reduce. Here I have an n minus 2, an n minus 3. Here I have a 3, a 2, and a 1. So really, all I am left with is n minus 1 over n minus 4. All of that algebra. Okay. One of the things that you could do to check this is you could sub in n equals 5. Okay. So in my calculator, I could do n, put n as 5, sub in my original, and make sure it's the same as my simplification. Okay, so if n was 5, so this is just a check here. If n was 5, I would have 5 minus 1, 5 minus 4, and I could choose any number to put in. I just chose the number 5. It has to be a positive integer is the only thing. Okay, so I have 4 over 1. I get the number 4. Okay, checking in to my original equation, 5 minus 1, choose 3, divided by 5 minus 2, choose 3. So is 4, choose 3, over 3, choose 3. I could use my calculator. Is that also 4? If you sub it in, you better believe that's 4 as well. So that's just a quick check you can do when you do these questions. Okay. And then, of course, there will always be questions where you're solving problems. Okay. How many ways can we get the mathletic coach to select a team of 6 grade 11 students and 7 grade 11 students if the team has 4 members? Okay, so I have 6 grade 7 students, 7 grade 12 students. I have a total of 13 students. Another one of my dreams is to be a mathletic coach. Okay, and I have to pick 4 of them. So that would simply be 13, choose 4. Okay, 715 when you put that in your calculator. Okay, 4 members, only one of which is in grade 11. So it doesn't matter the order. It doesn't matter if I choose the grade 11 first or second or third or fourth. Order doesn't matter. So right away I know I'm dealing with combinations. So really what I'm doing is I'm going to choose one grade 11, and then I'm going to choose other 3. Notice I use the word and, so I'm going to be multiplying these things together. So to choose one grade 11, I have 6 grade 11s to choose from. I want to choose one of them. Okay. How many other kids do I have to choose from? Well, I have my grade 12s. There was 7 grade 12s. Yep, 7 grade 12s. And I am going to choose 3 of them. Okay, so I will let you do this multiplication. You might have to use some brackets, or you might want to do each step at itself. Okay, we can check answers in class. I think I'll stop the video there because I'm getting close to 15 minutes. So before the second day for chapter 11, there'll be another video of the last question.